Hello folks. In this video, we're going to take a look at the while loop experiments, and we're going to use JavaScript to generate or simulate the flipping of a coin and to see how long it's going to take to get certain streaks of heads or how many heads we can get in a certain number of flips. Okay. So to set up the project, I'm going to use p5.js's random function. So I needed to go into the HTML file and add that dependency there. And now I'm going to be working in the JavaScript file for the rest of this. Okay, so our goal is to simulate coin flipping. Our goal is to count number of, well, we're going to do a couple different counts. Okay, so the first step is I'd actually recommend you to do this on your own a little bit, to pick a coin or find one on, the Google Coin Flipper and do a test, all right? And some questions are, after you do it, flip a coin 5 times and, or count how many heads you get, or set a goal of, okay, I want to get 5 heads in a row and flip a coin to get that amount, right? How long is it going to take? Okay. Or to get not even just in a row, but maybe heads in total, right? It should be about 50-50 split. If you're just trying to flip a coin and 10 times and see how many heads you get, we're expecting it to be about half, right? You have 50-50 shot between heads and tails. So we want to be able to do this and do it at scale, all right? And if you're going to try to, say, generate or flip a coin 10,000 times, how many heads do you get? Or if you want to get 10,000 heads, how many coin flips is it going to take? These type of questions are going to be hard and time-consuming for you as a human to try to calculate these things. Well, computers are great for this stuff. So what we need to do is write a program that handles this using while loops, okay? And the logic here is actually relatively simple. Let's make it easy for us by setting up a const variable called heads and let that equal 0. Let's set up another one, tails, and let that equal 1. Now we're going to be working inside the p5.js or using p5.js's random. So let's set up a function setup. And inside there, let's generate a random number. And because we have heads and tails 0 to 1, we're going to do that. So let's do const flip is going to equal random 1. That will generate up to a number 1. All right. And let's console.log flip, see what we got. Okay, we see decimal points, and we don't see a 1. That's because random is generating a random number up to that max number, but not including that number. So actually we need a 2 here instead of a 1. And we see every time we run it, we are generating 1 point or decimal points. Now we need to get rid of those decimal points. To do that, we can use math.floor, and we can wrap that random statement inside of it. So math.floor, parentheses, random2, will get us a random number 0 to 1. Okay, and we see that happening here. Now, to start off, we're going to flip a coin 10 times, and we're going to console log the value of each flip to the screen. So actually, to clean this up a little bit, I'm going to title this flip plus flip. Okay, so it's going to console log that flip, each flip. And now what we actually need to do is do a loop on this, or a while loop, okay? Generate a random number and a while loop. So let's go above it, and let's do while. Okay, and I'm going to copy this stuff and toss this inside of the while loop. Okay, cool. So now we see generate a random number and inside this while loop. And now we need to basically set a while loop condition. And in order to do so, we need to create a counter variable that will track the number of flips we're going to have. So let's do a const, actually it'll be a let let's see, total flips. We'll set that to be 0. And while total flips is less than, say, 10. That's our first goal. Let's count the total number of flips and make it less than 10. Now, because it's in a while loop, total flips is a century variable. It's watching over this while loop to make sure it actually ends. We have to actually go and increase that total flips variable inside by 1 every time to increment by 1. That way, eventually, total flips will eventually get to be 10, and it will stop. Okay, let's see if this works. Okay, good. So we see flip, and we see each flip 0 and 1. We see a lot of heads. Okay, inside there. All right, well, that's good. Let's see. So we created this. Okay, that's our first step here. Is starting simple, generating just zeros and ones, and console logging the value of each flip to it. And the other thing we're going to do is let's do a console log here at the end. Let's console log the total number of flips at the end. Display number of flips. Log total flips plus total flips. We put it outside the while loop so that it doesn't display total number of flips. We know it's going to be at the end. Okay, so 10. Okay, very good. All right, so the next step is we're going to take a look at counting heads. And the goal here is we want to limit the number of flips, okay? So total flips less than 10, all right? So that's only going to run 10 times, okay? But we're going to see how many times it's going to take to get a certain number of heads. All right, so how do we do this? And do we need to keep track of all previous flips? No, what actually we can do is instead of counting up the flips, counting up the heads and stuff, we can actually create a new variable that will handle this for us. So we can call this let heads count, or just head count. Let head count equal 0. All right. And inside of our while loop, okay, we can actually, let's see over here, let's see, count number of flips. Let's add that little comment there to clarify. Below, after we flip the number, or after we flip the coin, we can check. Check if heads. Meaning that we can say if flip is equal to heads, then we can increase this head count. Head count plus equal 1, like we did with our total flips, right? So we're counting the total flips, we're counting the total number of the head count, okay? And down here, display total number of flips. I think what we're going to have to do is actually, as a part of this while loop, let's console log, because we're already console logging the flip, right? Let's go and let's console.log head count. Head count. Okay. Let's run it. And we see that in 10 flips, we are able to get 3 heads, 6 heads. All right, we see it slowly increasing by 666. It's not flipping, and then it gets it. So 10. 10's the most heads we've gotten. 6, 4, 5. So we see the numbers on actually, it's not like a 50-50 split. It's all over the place, sometimes 8, sometimes lower. Okay, but this is the next step, right? So what we did is we add a variable that will keep track of the number of heads over time, and then we console log that out, okay, so we can take a look. Now, what I'm going to do is I'm going to take this console log flip. I'm going to move this down here so we can actually have this all at one spot down the end there. Okay, so we know what we're displaying out here. Okay, so that's good. So we have a while loop. We count out the number of ones, all right? So let's ask a different question, right? So what essentially this question is asking is, we have 10 flips. How many heads do we get in those 10 flips? Okay. Now, we can modify this, though, and we can modify it so that we can ask it a different question. And in this question, we could say, how many times do we need to flip in order to get a streak of heads? All right. And we can change that loop condition so that we can see how many flips it's going to take. So let's go up here. And in total flips, we want to modify that. All right. And heads count. Let's start off by doing 3. And because we changed if flip equals heads count, okay? It's basically going to keep track of it and going to run until DAS head count equals 3. All right. All right, let's give it a go and see what happens here. I'll heads count. Oh, whoops, typo here. Head count. There we go. There we go. Okay. So here we give it a test run. We see each flip generating it. We see head count increasing to 4. So we need 4 total flips on that one. Let's try it again. We need 5 flips, 9 flips, 6 flips. So this is pretty neat. What we just did is change our goal from having 10 flips and how many heads do we generate in 10 flips to how many flips is it going to take to get 3 heads. So it's a different question. It's a different question, but simply just changed up the loop depending on what question we're asking, right? So what are you measuring? What do you want to try to measure? And then how can you represent the while loop to do something until you reach that measurement, okay? Now, the next step is we're going to try to bump this up to see how many flips it's going to take to get 10,000 heads. All right. So this is something that we've talked about earlier, that these sort of large mathematical questions are time consuming for humans to figure out, but really easy for computers to figure out. So let's change our head count to be 10,000. Actually, we'll change it to be 7. Let's increase it by a small number first to make sure everything runs, and then we can increase it to something a little more taxing. And the reason is that everything at scale hurts. Like it gets more painful the bigger numbers you go. And the wait time increases, the computational requirements increases, your computer slows down, your browser crashes, nothing good. So let's see if everything works fine at 7. So our heads count 7. It's going to count the number of heads. It took 11 flips. Let's run it a couple times to make sure. 14 flips, 15 flips. Okay, cool. So we're actually seeing that it's getting a little bit closer to being a 50-50 split with our heads, meaning that basically heads are going to be half the number of represent half the flips that we make. 9 and 7. Oh man, browser's crashing. Okay. So we see total flips 14. Everything here is working fine. Apparently we crashed this. I don't know how. Come on. All right, with a quick screen refresh, we're back up and running. Okay, so now we can go and increase this number. But before we do, I want to move a couple things around. And in part because it's going to be faster for the computer to do so. I'm going to take that console log the flip. We're going to hide that with some forward slashes there. And I'm going to take this console log head count. I'm going to take this and I'm going to put it down here at the bottom so that it's outside the while loop. I don't want this. I just want it calculating. I don't need it displaying to me every 10,000 flip or every flip. I just need head count, total flips. Let's run it. Oh, sorry. Up here, we have to change this to 10,000. Let's go for a big number here. Okay, so the question we're asking is, how many flips is it going to take us to get 10,000 heads? Just total number of heads. How many flips? We get 19,000. Okay, that's pretty good. 20,000, 19,000. We see it's pretty close to being half. No 21s yet, though. But we see how fast the computer is to do this. This is not on my machine. This is on a web browser, and we see that this is pretty easy for it to do. A computer can simulate these ones and zeros very, very, very quickly. Okay, cool. So we see it takes 10,000, so 20,000 flips. Maybe you estimated that. Maybe you thought it was going to take double the amount of flips of what we want. 50-50 split, right? So this is pretty good. All right. All right. So next, let's move on to the next part of this, which is tracking streaks. All right. And what we're going to do is we're going to build up our simulation to ask a slightly different question. So we start off with, how many heads do we get with 10 flips? Next question we asked, how many flips is it going to take to get us 10,000 heads? The next one we're going to do is actually simulate how long is it going to take us to get a streak of heads in a row, meaning that you flip a head, 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 on and on. And we're going to build up our code to be able to handle a 12 heads in a row streak. All right. So we're going to begin by modifying our code just a little bit. All right. Okay. So in order for this to work, we're going to need to go to back up to our condition. Right. So we're going to try to keep track of a streak of let's say 12 heads total. All right, we're gonna limit this to keep it confined to make sure that this actually works before we go and actually and make this with larger numbers. So let's do while total flips is less than 10. We'll do this 10 times. Make sure our streak counter works. Right. Okay, so then how can we track the number of streaks in a row of head count? So, or, we can rename this to head streak, but it's the same thing, right? So, well, we already are doing that in a way. So we have a flip is equal heads. We increase the head count by 1. But what if we use this as a tracker for the streak? Meaning that if we flip a tail, we reset this number back to 0. Okay. And we can do this very easily using an else statement. If we flip a heads, we add 1 to the head count. If not, else, we actually give head count the value of 0, meaning we reset that count back to 0. Okay. All right. So now let's see, in order to track this, okay, we want the output of this. We want to take a look at we don't need to know the total number of flips. So let's hide the total number of flips. Let's keep the head count. Let's bring back the flip, console log the flip, and actually, let's take head count, and I'm going to move that under our flip, our console log flip statement. And I'm going to do that so we can actually see both things happening. Okay, so we see our flips, flip 1, head count 0. All right, so we flip a head with 0, and we increase that head count by 1. Up, we flip a 1, counter goes back to 0. Flip a 1, flip a 1. All right, so we're going. And out of, what do we say, 10 flips, we actually didn't get a streak higher than 3. All right, so that just shows us that our program's working. We can ask a question. How many heads in a row can you get when you flip a coin 10 times? That's our question. Okay. Now, let's move on to the next step, which is changing the loop condition to track the streak of heads in a row. But we want to do it so that, like we did before, we are counting the number of streaks in a flip of 10, but let's say we want to change this or ask a different question. This time we want to ask the question, how many flips is it going to take to get 3 heads in a row? It's a different question, right? So we have to modify this. So what we need to do is change this to heads, head count. We're going to change it to 3. Okay. While head count is less than 3, flip it. So just by changing that one condition, we've completely changed what this program is going to do. Instead of generating just 10 flips, it's now going to count the number of flips that we need in order to get a streak of 3. So once again, I think I'm going to... Do I want to change any of this? We'll just leave it as is right now. It's a pretty small number. Let's run it. Yeah, that worked out fine. Okay, so we see a flip of 0, head count 1. Okay, this is going to run until, here it is, we get our head count of 3. We get our streak of 3. So we flipped head, head, head. And we got head count 3. Okay, so this is pretty cool. So now we have a completely different, we have a use a while loop, but it outputs a completely different program just by changing what that while condition was looking for. Okay. All right. Last step. Okay. Last big one. How many flips is it going to take, okay, to get a streak of 12 heads in a row? Okay. 12 heads in a row. And in order to do that, first, let's bring back that display of total number of flips. I'm going to bring that back. And we'll see that we get a total flips of 15 to get a head count of 3. Okay. 6 flips, 11 flips. Our final question is, how many flips is it going to take to get 10,000, or sorry, 10,000. Yeah, that'd be a lot of calculations. To get 12 in a row, okay? All right. To do that, we're going to try to speed this up a little bit because I imagine the streak of 12 is going to require a certain number of flips. We're going to hide the individual console logging of flips. We don't need to know that. We don't need to know the number of heads each one, right? Or the streak, because we're gonna know at the end anyways. The program's gonna run until head count reaches a certain number. So in here, total flips, we want that. We want to know how many flips it's going to take to get 12 heads in a row. Let's make a small improvement to this. Let's do while head count's less than 7. Let's run it. We see total flips 61. Let's do head count. Let's do head count of 10 in a row. Okay, we see that number going up. That went up by a lot. 1,000 flips. 2,200 flips. You're going to do this on your own to get 12 heads in a row. You're going to be there a while, I think. That's probably just easier to let the computer do it. All right, let's give it its max number. While head count is less than 12, so while it's less than 12 in a row, let's see what happens. Okay, and actually, we see that perform that calculation rather quickly. We didn't ask for it to console log each statement individually. We saw that it took 6,000 flips. 6,000 flips to get 12 heads in a row, and 14,000 flips. 8,000, 800, 7,000, 26,000 flips. Wow, that's some unlucky numbers there. What's the lowest we can get? Get under 100? No, it doesn't look like it. The lowest I've seen is 15 flips. 15 flips to get 12 in a row. That is just pure luck. And it's not like all these numbers are generated beforehand, because it's a loop. You know, it's not like it could generate 15 and stop. The loop is going to run, and it's going to generate a new number every single time. So, yeah, these are quite a few. 22,000, 29,000. It's a lot of flips. Yeah, we see actually the computer be able to do this very, very quickly. All right, so high number was what, 29,000. Lowest I've seen is 15. That person should have gone to Vegas at the end of this. All right, and yeah, so that's it. So we went through, and I don't know if that matched your expectation of how many flips it's going to take to reach 12 in a row. But we look here, and you know, flipping tens of thousands of coins is going to take some time, a little bit of time on a computer. All right, depending on what you're working on for a machine. You know, if you want to simulate larger problems, it's going to take even more time for the computer to simulate them. Okay. You know, that's part of designing programs, right? So we think of computers to be pretty infallible, right? But it actually, we're operating right on the edge of making the computer slow down. I mean, here we're asking a simple math problem: generate a random number and check to see if that number meets a certain condition. And we entered in a number of different conditions to ask it if it met those conditions. You know, flip conditions or streak conditions. But simulations are, you know, they're not all as easy as flipping a coin, and very large simulations take a very long time to run. And specifically, if you're talking about physics calculations or, astrophysics calculations, okay, these type of things, you know, you take a 3D model and you try to generate, of a ship, and you try to generate the effect water is going to have on it, any sort of water calculation, fluid dynamics, thermodynamics. All these are pretty, weather and climate data models. All these are incredible simulations that are incredibly important to our daily life, but they do take a long time to run. And we see it here with a little bit of just flipping a coin simulation. And that's the part where I wanted to go over this lesson with you, is to show you the limits of what computers can do. And then it's not that far. meaning that you can't, you don't have to ask a lot of a computer to make it think for a long while. And that's part of it here, okay? So if you're going to do anything with chemistry, biology, anything scientific, you just got to be careful of what you're asking the computer to do, and try to reduce the number of steps. This also goes into like good programming as well too, is reducing the set of instructions to a limited amount so that you're not asking the computer to do too much so that it slows down your calculations. Eliminate the calculations or the steps that you don't need. We did it here. We got rid of the console log steps because having those actually slows down the calculation quite a bit. And we could show you that right now if you like. Let's just have it just console log the flips, every flips. All right. We have a console log heads count. Okay. And just asking that, we see the actual calculations happening. All right. Before it was instantaneous. We just asked it to run it. It would run it. This ran almost nearly 8,000 flips. Let's run it again. But it has to print all those off to the screen. Okay. And that takes time. So if you don't need it, to print those off to you, get rid of it. And you'll increase the calculation time or decrease the calculation time. And of course, this has a cost in real life, right? You rent servers, you rent CPU space, or you buy a computer that has a certain number of CPU or certain CPU inside of it. And that costs money. And so if you don't need as powerful machine to run those calculations, it's going to be it's going to be cheaper for you as well too. So there's a real benefit overall to making sure that we, 1, increase our computer speed, 2, decrease the instructions we're asking of the computer, and 3, just having a real clear goal of what we want before we try to program, because we saw that we were able to modify our program just by asking it a slightly different question and then representing that inside of the conditions of the while loop. So that's it. Thank you for watching, and I hope this helped explain how we can use a while loop to simulate coin flipping.